In 1993, the ACG, Automotive Components Group at that time, AC Rochester Division, requested Nail Paint Engineering's assistance in developing and implementing a paint process for the painting of truck grills. A partnership was developed and a team was formed to make this happen. What follows is an overview of the paint system, including background, history of the GM complex where the grills are being painted. The upfront testing, trials to develop the process, including benchmarking, and online development contributed in making this 2K paint system the benchmark for painting TPO and ABS grills in North America.
That decision was based in the need to improve the operation. The old system was manually done, and the levels of quality were kind of low and low productivity. Also, there was a decision to meet the commitment made in the labor agreement in 1993 that General Motors will improve the paint system operation in Plant 2.
The Plant 2 facility was originally built in 1915 as an assembly plant. It was the first building built by Chevrolet as a purpose-built building strictly for the assembly of automobiles. The plant built vehicles from 1917 until 1942. 60% of all the Chevrolets built in North America were built in this plant. This plant was the site of the first General Motors recognized UAW local. During World War II, the Plant 2 built armored cars, artillery shells, and military engines. After World War II, it became a die management site, followed by an injection molding facility, which it is today.
A very critical part of developing the new paint system here at Delphi Energy and Engine Management was to develop the process. And in looking at what we had to do, we had a benchmark, we had to make some visitations, we had to do some trials, and that was what we called Phase 1. And from Phase 1, we initially had layout sketches. We pretty much figured out what we needed as far as equipment.
As part of our benchmarking, we went to a number of facilities from different industries. We went to a few automotive paint shops, went to a number of part paint shops. We also went to paint shops that did paint work for things other than automotive or parts for automotive. Like, for instance, we went one that did snowmobile hoods. And each one of them had something unique. Every shop that we went to, we asked the question, if you had a lot of money or you do it over again, what would you do differently, or what would you improve upon, or how would you change things? And that was really constructive. We got a lot of good information, and we tried to incorporate a lot of those ideas in the design and build of our shop. When we designed the paint shop, the first thing we did was write a design specification. And a lot of that was based on what we saw and observed in other plants during our benchmarking visits and other information we picked up along the way.
When we first began, it's amazing to take a look at how many different layouts we went through before we finally arrived at the final design. Every possible configuration, because we were limited with space, we moved equipment in every different position on paper to see whether that would fit. So that was probably the lengthiest part of it, and we even used a design house that was not really set up for doing facilities work, was actually doing the layout work for us to get us started.
Once we went through Phase 1, we went into what we call Phase 2, and Phase 2 was a trial period of approximately 5 weeks at ABB in Auburn Hills, and we used their lab for that period of time. In fact, we had it for 5 straight weeks. And what we learned there, and the optimization results that came out, really gave us the final layout, told us what equipment we should use as far as robotics, multi-mix equipment, and as far as formulation, as far as the critical things in the formulation of the paint from Axle. So it was a very critical part of our development, and I can't say enough about using the 5 weeks and using it very effectively.
ABB, the main things I wanted to learn is what process parameters were really going to affect the appearance of the part the most. When we went to ABB, we were told the cycle time in which we needed to paint one part. Thus, the cycle time affects fluid flow. We knew we were going to have to run semi-high fluid flows to stay within that cycle time for which the job was quoted on. Knowing that, we went through the gun selection process, knowing how much fluid we were going to be locked into. We then adjusted the viscosity of the paints and the solvent blend type so that we achieved maximum breakup, which maximizes appearance. Doing this at ABB allowed us to have some time to develop solvent blends and not have to do that during production once we were expected to start producing parts. We knew what blend we wanted, we knew what viscosities we wanted to go with, and we were very confident that what we did at ABB was going to translate to Delphi the same. Probably the single most important thing that we learned at ABB during those trials was fluid flows. Not knowing the fluid flows and the type of gun that you're using, a paint company is often at a disadvantage when they are attempting to quality control their paint and ship it to the customer. Knowing the fluid flows in the guns gave us a big advantage in that aspect. During the several weeks that we spent at ABB, we evaluated, I believe, 8 or 9 different guns. We weren't held back on anything. We were allowed to look at HVLP, electrostatic, even an airless gun if we wanted to. We found HVLPs, while they provide superior performance in some areas, were lacking in others. Electrostatics, same thing. By the end of our trials, we generated data to show which guns were giving us the properties we wanted. So our final selections did go with the electrostatic gun, and the fluid flows that we needed to run through that gun performed well in breaking it up.
If I could have had one thing to change as we were in the process, or second phase of the process, I would like to have had the job setting personnel on the team with us at that point. That would have allowed them to have a little more understanding of the ground roots of the system, and there would have been less time involved in the training afterwards.
The use of idle facility equipment was very important to the success of the paint system. Without it, we could not put the paint system in. We weren't fortunate enough to have the money to be able to go out and purchase it all new.
We did that around $8–9 million, including labor, materials, engineering, transfers, and so forth. The key issue in reducing the cost was to tap on the corporate resources and being able to move use equipment from closed plants for open plants, assembly plants, Delphi groups.
Basically, the complete shell of the paint system was all retrofitted. The bake oven, all the paint booths, all the air handling equipment was all a retrofit. We were able to find the shell of the system in Framingham. It was all too large because it was for automotive use. Basically, we took the bake ovens as they were and cut the framework down, and they were mounted in place. So really the installation of the bake ovens and the dry-up oven was very simple. As far as the paint booths and the flash tunnels, and all that took quite a bit of work. There was a lot of cutting of panels and retrofitting of existing paint booths to fit our design. So that was quite difficult. Because of the volumes that we would be painting through our system, we were required to incinerate. And the only way that we could conceivably incinerate was to a recirculation type incineration. We did have an existing incinerator in our powerhouse. Unfortunately, because it was old and idled back, we really didn't have the volume capability there. Luckily enough, Delco Electronics at our East facility had an incinerator. And lucky enough, it was exactly really what we needed. So we were very fortunate, and we were able to get a hold of that incinerator and utilize that. So we do comply completely with all EPA regulations.
The paint kitchen, we were very fortunate. We were able to get a lot of our paint tanks, pumps, and other type paint equipment from a few other closed plants, mostly from Willow Run. But it all needed to be reconfigured, rebuilt, and reworked. So we were able to have an outside vendor go through, and he built them into modules very easily. Fork truck moved into place and out of place. In addition to that, we had to put blowout panels in and 12-inch thick cinder block walls filled with mortar, And it was quite a challenge getting all the approvals from the insurance company, the GM corporate people, the divisional people, as well as the plant people that had to build it. That was a lengthy process, and when it was all said and done, I think the paint kitchen turned out to be a real asset to us. We kind of insisted that anything that handled paint or had anything to do with the quality of the part, as for instance the robot, be new. The new stuff that was really, we thought would be important is the charge isolation equipment for the waterborne adhesion promoter, all of the paint guns and paint handling equipment, the two-component mix equipment, the color change valves, and the robots.
The washer we felt was very critical. The availability of finding a washer that would fit our system and our needs was not likely, and all the washers that we had looked at were basically all mild steel, heavily corroded, and as far as the proper construction and times and zones would not match our system. So we knew that we would have to purchase the washer new and not be able to find that.
From the construction point of view, we use 100% skilled trades on site. In a very exceptional location, we use contractors to come and work in the plant. We have all the facets of the construction skill members, from pipe fitters, electrician, building and repair, welders, torchers, tin knackers, etc. The key element in this activity was that we sent our skilled trades to those close plants to take a look at the equipment, and at the same time we were developing the retrofitting design. They were working with us, with the engineers, so it was like a time and mutual effort that helped us to overcome a lot of constraints, like just picking up a blueprint.
Some of the complexities of installing the system was some of the facilities work, cutting holes in the floor, preparing for the pits, the main sludge pit, which was located right underneath one of our main booths, or off to the east of it. I'd say the largest complexity was not having a complete design and having to change so often. We had to go in and retrofit and change many times because we didn't have it fixed.
Our paint system is unique in that it paints two different substrates, both of which are unique to our plant. The TPO and the ABS are unique to our facility, and the paint system used, the Axo Nobel coatings, as well as the PPG waterborne adhesion promoter, were unique to our facility. So we had to conduct complete APOPS testing on production parts that were painted on our system through entire step 5 of APOPS. All this testing was done both at our site and at Axo, so that we got duplicate test results that satisfied General Motors that we had good performance.
As a paint supplier, the fact that we were involved right from the beginning helped us to have input in the equipment that was chosen to apply our product, and then also being able to see what conditions were going to be, the product was going to be applied in, gave us the ability to put together standard operating procedures to allow us to set up our equipment back in our facility in order to ensure good quality product coming into site.
One of the things that held us back in the development of the process and the finalization of production was that we were having to run production while we were running process development. This meant that we only had 5 hours per day to actually set up and run process trials. And it takes almost 3 hours just to get results from your first trial. So it was somewhat difficult to get fast results and fast process development in that situation.
All in all, that was the biggest problem, that we didn't have enough time to do our process and shop development before we went into production. But that we worked through that, and it was a good learning lesson for everyone.
One of the unique features of our paint system was a universal paint buck. This enabled us to minimize or eliminate tooling changeover times and give us electrostatic efficiency through a grounded aluminum carrier. This part is universal to all our grill configurations and enabled us to save labor cost as well as time.
We went through quite a lengthy process to finally realize that we needed a new conveyor and we couldn't put a used conveyor in. The problems we had with the conveyor system were related to the design. Unfortunately, we had a lot of rises and falls in the system. Just based on the way we had to design the system, there was a lot of elevation changes. And this caused a jerking in the system, and it was difficult for the tracking. In the initial break-in period, we had quite a time actually slowing down the conveyor so that it had a consistent movement. And we called in the experts to come in, and it baffled even the experts on really what to do, because everything measured out okay. There was no component in the system that really should cause it to do that. And we believed that it was just the slack that was caused in the elevation changes. So what we did to really to help this or correct the problem was to install a drive in line with the main conveyor, and that really helped the problem.
The automatic masking system used at Plant 2 is one of a kind. It uses 2 spray booths, 2 robots, and 2 pick-and-place units in tandem with each other. It is the only facility of its kind that has automated mask painting using a 2-component urethane paint. All of the equipment that handles the fluid is the same as our mainline system. We're using Graco Precision Mix with ABB robots. However, this is not electrostatically applied. The paint is applied through an HVLP type gun. The system is one of a kind. No one else in the world right now is masking with 2-component urethane coatings in a fully automated system like ours.
The mask system is completely self-contained. And the reason that we did this was to isolate it from the main line so that we wouldn't ever hamper the production of the main line based on any downtime possibilities of the mask system. The part is removed from the main line with a pick and place and is placed into the mask system. And we used hard masking. It's not a typical masking where you may tape it. It's actual hard tooling which is lowered onto the part, and then the part is masked.
The Nordson IsoFlow charge isolation system that's used by Plant 2 is unique in that we're the first people in the auto industry to use this piece of equipment, and it's there for the safety of our people. It isolates the charge on the paint to just that part of the fluid handling system, so that if an operator comes in contact with that paint outside of the booth, they don't get an electric shock. It's a safety factor, and it also helps maintain a high charge on the paint. The fluid handling system in our plant is quite unique. We have 2-component mixing equipment capable of multiple ratios. We are using both monocoat and base coat clear coat systems, all controlled through part numbers. Finished part number determines which coatings are dispensed and in what ratios. Everything is on a closed loop system, which enables us to get data and feed back into the process what our parameters should be and maintain very tight process control on fluid delivery, ratio, and all the other properties that affect paint delivery. The fluid handling system is unique in another way. We use a proprietary blended purge thinner that was designed strictly for our system. We use Teflon hoses throughout, and this proprietary blend from Grow Chemical enables us to run many flush cycles with many colors without having to change tubing. In some cases, we've gone for almost 2 years without changing a fluid line. It's a very efficient cleaning solvent, and it's worked very, very well for us, and it's tailor-made to our application.
One of the plants had purchased a smart screen setup and all the software required to program and set up your own screens, and we had a controls engineer, Chris Bacon is his name. Chris went through and did an outstanding job in setting up this to monitor and tell you the whole status of the paint shop at any time, tell you if it was in a caution situation that requires look at, and shut it down if need be. For instance, on the washer's a couple of 100 feet from the control room, and in the control room you can sit there and check the washer temperature in each of the 4 stages, check if the pumps are running or not, and there's a lot of precautionary things built in, and he's interlocked it sufficiently that you couldn't run a part through the system or even get the conveyor to start unless everything was the way it should be. So the controls engineer and the smart screen software was a real big tool that helped us succeed.
The dunnage that's used in our process is a styrofoam layered dunnage, which is used for both in-process as well as shipping parts to the assembly plant. This eliminates scuffing, scratching of parts, damage in handling as well as in shipping. The material is 100% recyclable, it's returnable dunnage, and the cost is minimal compared to the scrap rate that might be generated by another form of racking or fixturing.
Basically, the cap cleaner, a gentleman from Crystal Cap Cleaners, brought us one to try. Before we had these cap cleaners, what would happen as the line would run, we'd run parts down the line every 40 or 50 parts. We would end up shutting the line down, pulling the gun over, going in and manually taking a cap off, cleaning a cap, take the cap, bring it down to a wash station, manually wash it off, put the cap back on. We wasted a lot of time, we lost a lot of parts by manually having to do this. Call it a coffee can with a lawn sprinkler inside of it. All it does is inside the stainless shroud, there is 4 nozzles on a rotary arm. Basically all it does is it's programmed for every 30 parts coming down the line. The robot will go over into the cap cleaner. For 10 seconds, it will spray a fluid or purge thinner on the cap to loosen the paint up and wash the paint off the cap. Then for 20 seconds, it blows air on the cap to dry it. So basically, every 30 parts coming down the line, it's doing a cap clean. We can sit here now and run constantly all day long without ever having to go in and change a cap.
The paint system is designed to paint 2 different plastics, ABS and TPO. During the course of our process development and building the line, we found that we needed to heat treat the adhesion promoter to 250 degrees Fahrenheit in order to get performance in adhesion and thermal shock resistance. So therefore, we put in an infrared oven in a flash tunnel stage between the adhesion promoter and base coat that gives us 5 minutes at or above 230 degrees Fahrenheit and enables us to get a better quality part for adhesion performance, thermal shock, and overall appearance of the part.
One of the keys to keeping a paint shop running after you get it all built and running acceptable or high quality production is to keep the equipment in that type of condition. And we're real fortunate. We have a very strong preventive maintenance program here, and a machine repairman actually coordinates most of it. And I spent many days walking through each piece of equipment and pointing out bearings, filters, all kinds of miscellaneous parts that if you handle them on a preventive maintenance or predictive maintenance plan, you can avoid a crash maintenance program when a thing breaks in the middle of the night.
Training is very critical with robots. Robot programming training is essential and fundamental to what we did in our system. A lot of the training that was done with our robots was strictly on-the-job type training. And if we had it to do over again, I feel we probably should have put more time into off-site training and brought the operators in earlier in the development process to enable us to bring them up to speed and help them understand the important parameters that had to be controlled. Another part of the system where training was essential was on the proper handling of the fluid systems, pumps, the regulators, and all the equipment that goes with it. People were not given a chance to really learn the reasons why equipment was set up the way it was. We learned by trial and error. Training was more or less by trial and error. And for that reason, I think if we were to do it over again, we would bring those people in earlier in the process and have more formalized training for that purpose. When we started with the monocoat system, our first-time quality was 35%. We are now running between 98 and 100% first-time quality parts. For the high-gloss base coat clear coat systems, we started out in the 40% range, and we are now running 85 to 95% good parts, with a good portion of those parts that do not pass first-time quality going to finesse.
The appearance level of the parts coming off the line have a DOI of 85 to 95, a gloss of 80 plus, in a orange peel range of 8 to 9.
Our quality laboratory uses state-of-the-art equipment. We have data pack for temperature recording of all of our processes. We have a microscope system that uses both a video monitor, a computer data storage, and a digital camera. Therefore, we're able to build a book or a library of dirt defects and paint defects, which enables us to communicate this information back and forth between ourselves and NAO Paint Engineering, as well as Axo Nobel and PPG on dirt detection, defect detection, and quality. We also use state-of-the-art testing equipment in terms of temperature cycle testing, gravelometer testing, and environmental testing. So our laboratory is very well equipped to test not only grills, but any plastic component that's painted. One of the tools that we use in our lab is the X-ray color measuring system. This has helped us communicate color quality back and forth between ourselves and Axo Nobel, as well as to our customers, the truck assembly plants. For this reason, we have had 0 rejections for color, either coming from the Axo Nobel facility or going to the truck assembly plants since we started production of high-gloss parts.
The highlights, I think, was experiencing something that was so new that none of us had ever really done before. We had experienced people helping us, but as far as Delphi was concerned, we really didn't have that kind of experience. So we had so many new things to learn.
Basically, the partnership that was formed was unique. All the years I've been in paint, I don't think I've seen a partnership that was that well formed and basically worked together as well as we did. And I think that indicates to people starting a new paint system that you need to look at forming partnerships and having good relationships to make the system work and work well.
Probably the most important question or most important thing that I learned through the project is the importance of teamwork. We had a great team, everybody working together. There was no stones being thrown. We'd run into problems and the problems were solved rather than trying to find fault with why did this happen. So it was a very good, productive atmosphere to be in.
The key success in any project is the people and how you communicate and identify what the team needs. If any one of you is a project manager, your job is not to push everyone, but to be a counselor, a friend, and listen to the true problems that can jeopardize the total project. I never tried to solve the problems for them. I was there when they asked me for help. I was there to support them.
Being from a technical end of Axo Nobel, being able to be on the front end and working with GM in this partnership, to actually doing the gun selection and knowing what sort of cycle times or fluid flows we had to live with, that helped us immensely in fine-tuning our products.
Of the lessons learned on this system, I feel that training and process control are both critical to the success of the project. Good training both on the job and prior to the project starting up are very critical, and process control makes everybody's life a lot easier. So those two go hand in hand together to make a successful project.
I guess one lesson I learned is to be really good at something, you don't have to know everything about it, but you have to know where to go to get the answers. And we were real fortunate to have assets such as NAO and a lot of our vendors that really came to bat and were able to answer our questions and lead us in the right way. And that's a real key reason why we were so successful.
We always say that if we fail, it's my fault. If we win, it's your credit. And I think they succeeded.